Hello guys, is coming to the second part of this atomic structure series. Here we are going to study about Bohr's postulates. This is a very important topic. First part we are going with the basics, later on we will do the application part. So, as you know, Rutherford was not able to explain its model properly. Okay, it has some drawbacks. These drawbacks were overcome by Bohr in his theory. So coming to this Bohr's postulate, this first postulate is just the revision of Rutherford's concept, which is similar to our solar system. This concept says that electrons are revolving around the nucleus in specific orbits. Okay, so this is your electron which is revolving in the nucleus. Now this is the nucleus part. Okay, and inside the nucleus we have protons, which are together also known as nucleons. What do you mean by nucleons? Nucleons means the subparticles which are lying inside the nucleus. Moving further, now the question which arises is electrons are negatively charged and protons are positively charged. Okay, that means the electron should fall inside the nucleus because protons should pull the electron and it should fall inside. But why does not happen? This is a common question which is generally asked by the students in the class. So the explanation to this question comes from the second postulate. So what is it? Negatively charged electrons are moving around the nucleus, and how is it getting balanced? Now the same things are balanced. So which forces are balanced? Let us check them. So actually the force of attraction towards the nucleus. Now how is this created? That's what I was telling you. This will be called as which type of force? This is called as a electrostatic force. That is the force between the proton and electron. Now this is balanced by the centrifugal force. This is a force which you will study in physics, and it is related to any body revolving around. Same way, you know, satellites revolve around the earth to gather. Class 9th and 10th you might have studied. Over there also the centrifugal force is balanced by the gravitational force. That is the explanation why moon does not fall into the earth's gravity. So now, out of infinite number of possible circular orbits around the nucleus, the electron can revolve only on those orbits whose angular momentum is an integral multiple of h upon 2 pi. Okay, fine. That means the values of n should be 1, 2, 3 and so on. But it cannot have any kind of fractional value. No fractional values are allowed. Okay, so angular momentum is said to be quantized. The specified or the circular orbits are also called as their stationary orbits. This means, now supposing this is the nucleus and you want to create an orbit over here. Okay, so that is not going to be your choice that you want to create an orbit over here, so you can create it. No, that's not possible. The orbit has to be quantized. Quantized means it should be in the multiples of nh upon 2 pi. Fine. So what does this basically mean? That my orbit will be made over here. This is the correct orbit. Why? Because in this particular case, the mass of the electron, the velocity of the electron and the radius in the orbit in which it is moving, it is coming in the multiples of nh upon 2 pi. Like for example, for the first orbit, the value of n is going to be 1. So that's why my first orbit. Similarly, for the second orbit, n is going to be 2 and so on. So supposing over here this multiples they came out, so this is my first orbit. Similarly, after some time there is second orbit. After some time again the multiples were equal, so I get on into the third orbit and so on. Now, what does it mean quantized? Quantized means you cannot have 2.5 of an orbit. It is just similar to that of a staircase. First floor, second floor. No, there is no stopping at the 2.5 floor or 2.8 floor. So you don't have 2.8 of an orbit either. It is on to the next particular postulate. So what is this postulate telling us? That if the electron remains in its stationary orbit, it will not lose any kind of energy. Fine. Okay, and that is why it is called as the ground state or the normal state. What is the most stable state for you? Your home is the most stable state for you. Similarly, if the electron, this is the house of this particular electron, for example, fine. So the electron belongs to this particular orbit. Why does it belong to this particular orbit? Because the velocity of the electron, the radius of this particular orbit, and the mass of the electron, when we multiply all these things, it is coming in the multiples of h upon 2 pi. So the electron is belonging over here and it is very happy over here. So that's why this orbit becomes the home of the electron, which we represented as which state? Ground state or normal state of the electron. Now supposing I am talking about this orbit. Okay, so this is not the home of the electron. So this was home, this is not the home of the electron. Now if you move out of your house, what will happen? You will need to spend money. So this is what we later on study. It is called as the excited state of the electron. What is the difference between a ground state and the excited state? In ground state, it is just like your home. Home means there will be no energy evolved if you want to revolve. Like if you are in your home, you don't need to spend money. Your parents take care of your expenses. But supposing you are going for an if you're going out to a market or you're living there in an hotel, so obviously you need to spend money. So that similarly, if you're in the excited state, to survive over there, you need to emit energy. Okay, so that is the difference between. That's why we say that ground state is the most stable state, because to revolve in the ground state, we don't need to emit any kind of energy. Now over here it is said that each stationary orbit, obviously each orbit will have certain amount of energy, because if you want to revolve, कुछ काम करना है तो एनर्जी तो चाहिए ही ना, चक्कर लगाना तो एनर्जी चाहिए ही चाहिए. सो इसीलिए हर एक स्टेशनरी ऑर्बिट के पास एक डेफिनेट अमाउंट ऑफ एनर्जी की ज़रूरत पड़ेगी. अब सपोजिंग 200 मीटर्स रनिंग कर रहे हो, 400 मीटर्स रनिंग कर रहे हो, सो 400 के लिए ज़्यादा एनर्जी चाहिए. Similarly, so that means greater the distance from the orbit, so greater will be the energy associated with this. अब उसने एक और काम किया. Sometimes it is very difficult to call it as first orbit, second orbit, so उसने एक नाम दे दिया उनको. So like for example, this is the first orbit, he named it as K shell. Okay, second orbit he named it as, मतलब नामकरण हो गया यहाँ पे. Second orbit के लिए क्या नेम कर दिया उसको? L shell. And you can say third orbit का फिर से नेमिंग आ गया, that is M shell and so on. मतलब इसके this is the part which I already told you. बड़ा orbit होगा, so you require more energy, so obviously energy required to revolve around the first orbit is lower than second, then third and so on. Okay, the emission or absorption of energy in the form of radiation can only occur when the electron will jump from the one or stationary orbit to the another orbit, or and this is what it is given. I'll explain it in the next part. The energy is absorbed when the electron jumps from the inner to and it is emitted when it is coming from outer to inner. When the electrons move from inner orbit by absorbing definite, it is the new state, and this is also called as excited state. अब ये मैंने तुमको पढ़ के बता दिया है, read कर लो अच्छे से. Now let's move. So whatever you have studied in postulates, let me explain it to you in an extensive and a better manner. Supposing this is my hydrogen atom. Hydrogen atom, you know, there is only one electron. ठीक है, so वो electron कहाँ रहेगा? First orbit में. So this orbit, or you can say first orbit, is the ground state of the electron. Now अब आप ऊपर जाने के बारे में सोचते हो, you think about growth. So the electron is also ambitious, just like you. So what will happen? It will try to jump to the higher energy levels. Okay, so it can jump from first energy level to second energy level. Now this is not the ground state of the electron, क्योंकि यहाँ का angular momentum उसके nh/2 pi वाले multiples में नहीं आ रहा है. So this is what the excited state of the electron. Similarly, more ambitious हो तो और एक jump कर जाओगे state. So this is again the excited state of the electron. Now what is the difference between ground state and excited excited state. Ground state में रहने के लिए कोई energy emit करने के लिए ज़रूरत नहीं है. It is just like your home. In excited state, it is just like an hotel. You need to pay for your stay. So over here, if you want to revolve and sustain, you need to spend some amount of energy. That's what the electron is doing over here. Fine. So already you have done in the earlier thing that as you move away from the nucleus, more and more energy is required. So E3 की energy ज़्यादा होगी as compared to E2 and then as compared to E1. So यहाँ पर E1 में survive करने के लिए इलेक्ट्रॉन को less energy चाहिए. So it is having less. So if you want to jump, if you are ambitious enough, so you need to absorb some type of energy. That's what the electron is doing. From any source, if electrons tends to absorb energy, it can be light source, heat or anything, the electron, when it has sufficient amount of energy to survive in the third energy level, the electron jumps from first energy level to second or third depending upon what is the case. So electron energy को absorb करेगा, and you know already we have done this is in the form of a photonic. Photon को absorb करेगा and it will jump from one state to another state, higher energy level. Okay, now this is not your home. This is the excited state. So what will happen? यहाँ पे रहना है तो energy spend करनी पड़ेगी. You need to spend energy to survive over here. So after some time क्या होगा? Your money is going to get exhausted. So क्या हो जाएगा? गुस्से में घर से चले तो गए, लेकिन लौट के बुद्धू घर को आए. So after some time what will happen? When you are going to spend energy and there is no source who is giving you a backup, so obviously you will try to return back to your home. So the difference of energy, यहाँ पर रहने के लिए कहाँ से कहाँ जंप मारा तुमने? E3 minus E1. This will come in the form of energy can neither be created nor destroyed. तो ये भी किस form में निकलेगी? It will come in the form of a photon. And what is the energy of a photon? Already done in Planck's constant, h nu. So that is the electron emits a photon when going down to the energy level. So more clearly it can be explained over here. See, just for a when the electron is jumping to the higher energy level, it will absorb energy, and when the electron is emitted, because that is not the stationary ground state of the electron, it will emit energy, and this will come in the form of energy of a photon. So that's about Bohr's postulate. I hope this works out for you. Stay tuned for more such updates. All the best for your studies. Thank you. Don't forget to like and subscribe. That will just be a motivation for me.